Right now, a cloud of charged particles from the sun is racing toward Earth at over 1,000,000 miles an hour. It left the sun aimed almost straight at us. The warnings have already gone out, satellites are being watched, and power grid operators are on alert. The question is no longer whether it reaches us. It is how hard it hits. So stay with me until the very end, because the most unsettling part of this is not the storm arriving now. It is what this storm is quietly rehearsing for. And the last 30 seconds of this video will change how you look at the sun. In the last few weeks, our star has come alive. The sun runs on a cycle roughly 11 years long, and right now it is at the peak of that cycle, the phase astronomers call solar maximum. During this stretch, its surface is covered in dark, magnetically twisted regions called sunspots, and lately, those regions have been firing. In a single day, one of them unleashed a chain of solar flares, including an X-class flare, the most powerful category we can measure. And a flare is only half the danger. A solar flare is a burst of pure radiation, and it crosses the 93 million miles to Earth in about 8 minutes at the speed of light. There is no warning. By the time we see it, it is already here. But the flare is not the thing that reaches down and touches the ground. The real weapon is slower and far heavier. It is called a coronal mass ejection, a cloud of billions of tons of charged plasma blasted off the sun and hurled out into space. That cloud moves slower than light, taking a day or two to arrive, and that delay is the only reason we get any warning at all. In the last few days, one of those clouds launched in our direction. So here is what happens when it gets here. The cloud slams into Earth's magnetic field, and the entire field begins to shake. We call that a geomagnetic storm. For most people, the visible result is beautiful. Auroras, the northern and southern lights, pushed down from the poles into skies that almost never see them. People will photograph them, share them, and assume the light show is the whole story. It is not. Because that same shaking magnetic field is doing something invisible at the very same moment. It is forcing electric currents into anything long and metallic on the ground, and into the delicate machines flying overhead. In the next day or two, as this storm arrives, here is what is genuinely at stake. GPS signals can drift, throwing navigation off by meters, sometimes far more. Airlines reroute flights away from the poles, where the radiation and the radio blackouts are worst. Radio communication can go dark across whole regions on the daylit side of the planet. And satellites, the ones we lean on for weather, navigation, and internet, feel the upper atmosphere swell and drag against them, while charged particles pile up on their surfaces and can fry their electronics from the inside. This is not theory. A few years ago, a single moderate storm caused the atmosphere to swell just enough to drag a fresh batch of newly launched satellites back down out of orbit, destroying around 40 of them in one stroke. And back in 1989, a geomagnetic storm hit the power grid of Quebec in Canada and collapsed the entire thing in under 2 minutes. 6 million people lost power in the middle of winter. That was not the big one. That was a medium storm finding one weak grid. Grid operators around the world remember it, which is exactly why they are on alert tonight. And the storm arriving now will very likely pass without disaster. We will probably get the light show, a few glitches, some nervous engineers, and then it fades. So you might be asking, if this one is survivable, why does any of it matter? Here is why. Because everything I just described is a rehearsal. The sun is at the peak of its cycle, throwing these storms at us again and again, and almost every one of them is a smaller version of something far worse. The mechanism is identical every single time. A region on the sun snaps, a cloud of plasma launches, it slams into our shield. The only variable is size. And the sun is fully capable of firing one many times stronger than anything in living memory. That is the part nobody likes to sit with. and it is the part I promised you. We already know what the big one looks like, because it has happened. In the year 1859, a storm now called the Carrington Event struck a world that had almost no electrical technology, and it still set telegraph lines on fire and sent sparks leaping from the equipment. If a storm of that size arrived today, it would not be a light show with a few glitches. It could drive currents strong enough to overload and physically destroy the giant transformers that hold up our power grids, machines that are custom-built and can take a year or more to replace. The result would not be a blackout of hours. It could be months, across entire continents, taking water systems, fuel, refrigeration, and the internet down with it. And before you file that away as a once-in-a-thousand-years event, consider this. In 2012, the Sun fired a cloud exactly that powerful straight across Earth's orbit. The only reason it did not hit us is that it crossed the spot where Earth had been just 9 days earlier. We did not survive it because we were protected. We survived it because of timing. We happened to be somewhere else that week. So why do these storms keep catching us off guard? Part of it is that the warning is brutally short, a day or two from the moment a cloud leaves the sun, and only a rough guess at how hard it will hit until it is almost on top of us. Part of it is that the threat is completely invisible until it arrives. A hurricane you can track for a week. A solar storm you mostly discover when your instruments start screaming. And part of it is simply that we have been lucky for so long that the luck has started to feel permanent. But we are not in a quiet stretch. We are at solar maximum right now in the exact window where these storms come most often and hit hardest. The flares of the past few weeks, the warnings, the auroras drifting down toward places that rarely see them, none of it is random. It is the sun, at the loudest point in its cycle, showing us what it can do. And so far, every single time, it has been holding back. To be clear, the storm reaching us in the next couple of days is almost certainly survivable. You may never notice it beyond a headline and maybe a glimpse of the aurora. The danger was never this one. The danger is that this one proves the gun is loaded, the trigger keeps getting pulled, and one day the storm that launches in our direction will be the big one, on a day when Earth is sitting directly in the line of fire. And it is worth slowing down for a second to picture what the morning after a big one would actually look like, because it is nothing like the movies. There is no explosion, no fire in the sky. You simply wake up and the power is out. Your phone has no signal. The tap may run for a while until the pumps that need electricity fall silent. The stores cannot process payments. The fuel stations cannot pump. And the internet, the very thing we would all reach for to find out what is happening, is exactly the thing that is gone. The most frightening part is the slow realization that this is not a blackout that ends by morning, because the transformers that burned out in the night cannot simply be switched back on. They have to be rebuilt, and there are nowhere near enough spares on Earth to go around. That is the difference between a blackout and a collapse. So here is my question for you, and I genuinely want your answer. If a storm the size of 1859 hit us next month, how long do you think the modern world would take to recover? Days or years? Tell me in the comments below. And if you want to be here for the next move our star makes, because at Solar Maximum there will be a next move, subscribe and turn on the bell. This channel follows one real signal from space at a time, and the sun is not finished with us yet. Because the most dangerous thing about a rehearsal is simple. Sooner or later, it means the real performance is on its way.